equation, and we have y double prime minus 30y prime plus 25y equal 25x. So first thing we have to do is step one, we solve the first part, we solve the homogeneous equation for this differential equation. So we're solving the homogeneous equation. So we're ignoring the equal 25 for now, and we're solving y. 9y double prime minus 30 y prime plus 25 y equals 0. This is what we're solving now. That is step one. So first thing now, if we're solving this, right, then the homogeneous, solving this now, we'll solve the auxiliary equation for this, which is 9u squared minus 30u plus 25 equals 0. All right, that's what we do first. After we do that now, when we solve this, we're solving this our auxiliary equation. So let's go ahead and solve this. I'm going to factorize it. Looks like it can factorize easy. Looks like it can factorize easy. I'm not quite sure as yet. 25, I know 25 must be 5. Well, I'm hoping it's 5 and 5. Let me see, 5 and 5. Signs are the same, both of them negative, so that's minus, minus. So this looks like 3u, yep, 3u, and this also looks like 3u. So what we end up getting is u is equal to 5 over 3. Repeated, u is equal to 5 over 3. So therefore the complementary function, I like to call the complementary function yc. So the complementary function yc is equal to, it's e to the u times x, or e to the 5 over 3 times x times in bracket a plus bx. A plus bx. This is our complementary function. But now we need to find our specific solution. To find our specific solution, we look at what is given right here. All right. So we need to use this to find our specific solution. So first thing we need to do is write down our particular integral. Since it's equal to 25x, then we know our particular integral is going to be a linear equation. So we're going to call our particular integral, usually it's with pi, a particular integral. We're going to call it yp, and our particular integral is equal to, our particular integral, since it's 25x, it's going to be linear. So I'm going to write it as cx plus d. That's our particular integral. So when we differentiate our particular integral, yp prime will be equal to c, and then when we differentiate this again, yp prime prime is equal to 0. So using this, we're going to substitute all of these in this equation up here. So what we're going to get is substituting it. That implies 9 times y double prime, 9 times 0 is of course 0, minus 30 times y prime, or y prime is c, is minus 30c, plus 25 times y, where y is cx plus d, cx plus d, and that is equal to, of course, equal to 25x. This is equal to 25x. Yeah, man. So we're nice. So solving this equation, what we're going to get is minus 30c. This looks like plus 25cx. That looks like plus 25d. is equal to 25x. So what does that mean? All we have to do now is look at this. Equate the x term them on each side. So that means 25cx equal 25x. So 25cx is equal to 25x. And so what that then means is if you solve this equation for c, you can divide both sides by 25x. Divide both sides by 25x. Divide both sides by 25x. So what you would end up get is c equal 1 because the x will cancel, 25 will cancel, you end up get c equal 1. So c equal 1. Then now you have minus 30c plus 25d. And we do have a number over here, so this is really plus 0. So the next equation we have is minus 30c, but c is 1, so it's minus 30 times 1 plus 25d plus 25d. And we know this is equal to 0. And so we can bring over the 30 over here to get 25d equal 30. Then we divide both sides by 25. Divide both sides by 25. Divide both sides by 25. And so what happened is this 25 cancels this 25. So we get d equal 30 over 25, which is simplifying 30 over 25 is 6 over 5. And so what that means is that our particular integral yp, so finish it off over there, our particular integral yp is cx, where c is 1, which is x plus 6 over 5. Nice. So now we can go back and write down our general solution. So our general solution now, the general solution, by the way, the general solution, y, remember it's equal to the complementary function plus the particular integral. That's how you find general solution. So the general solution is equal to the complementary function of e to the 5 over 3 times x in bracket a plus bx, and then plus our particular integral. And our particular integral is what we got again, x plus 6 over 5. And this would be the general solution. Nice. And if you don't believe that this is true, what you can do if you have time, you can remember all of this is y. What you can do is find dy by dx, multiply it by 30, find the second derivative, multiply it by 9, and then work out 9 times second derivative minus 30 times first derivative plus 25 times this y, and I guarantee you're going to get 25x. So if you have time, you can do that to check your answer. We won't do that right here. That will take a lot of time. So this is the general solution.